Final video of 3, and this is problem number 5. The problem was you have f of x is equal to x squared plus b of b plus 1 times x plus 2c. We are given that f of 2 is equal to 4 and f prime of negative 1 is equal to 2. Okay? So when the original equation x equals 2, we're going to get a 4, and the original equation when, in the derivative of the original equation when x is negative 1, we get a 2. All right, now, it may not look like it at first, but this is actually kind of a simple problem. When you take the derivative of something, this will become 2x. This, since x is to the first power, will just become 1 times b plus 1. Because remember, this is just the number, this b plus 1 is actually taking place of just the coefficient in front of x. Okay? 2 plus c, there are no x's, so that will just disappear. That's actually incredibly important information, because if you take the derivative, we just talked about it, x squared becomes 2x. This is to the first power timesing that front. X becomes to the 0 power, disappears. So it's just b plus 1 over here, and that disappears. If you can see, now we are missing that last value, plus 2c. So we only have one variable to solve for, b. We already know what x is. How do we already know what x is? We were given it from here. So as long as you take the derivative, and you know you probably should take the derivative because you're taking the class calculus. So if you're told what the derivative of what negative 1 is, you know you're probably supposed to find the derivative. So just go ahead and derive it. Once you look at this, well, you already know what x is, therefore the only thing left to solve is b, and you're already told what y is too. So if I need to say it again in a different way, every time you take the derivative, you're going to lop off one of those pieces at the end. Since we lop off one of these variables, there's only one left to solve for. Why is there only one left to solve for? Because we already know what x is from the beginning. It's going to be negative 1. So we'll do that. Since we know that f prime of x is equal to negative 1, and that when you plug in negative 1, you get 2, we're going to do that. We're going to plug in negative 1 and then set it equal to 2. 2 times negative 1, since the problem, by the way, is 2x plus b plus 1, that plus b plus 1 doesn't need to change. You just can get rid of the parentheses. Okay? Negative 1 for where x is, so 2 times where x is, negative 1, plus b plus 1 equals 2. 2 times negative 1 becomes negative 2. Again, you can get rid of that parentheses and just be b plus 1. So it's negative 2 plus b plus 1 equals 2. Simplify, add 2 to both sides. B plus 1 equals 4. Subtract 1 to both sides. B is equal to 3. Okay, now you know what b is. Well, great. What do? Well, we're told what the original equation is. We already know what x is. It's going to be 2. We already know what y is. It's going to be 4. We already know what b is because we just solved for it. It's going to be 3. So you have plug in all the values here, and the only thing left is c. Let's go down here. So here it is. There's the original equation with b plugged in, where b is 3. Simplified out, it's now x squared plus, with b solved out, it's 4x plus 2c. And now we're going to plug in the numbers that we know. X equals 2, y equals 4. Okay? So all the x's now become 2's. So it's now 2 squared, 4 times 2 plus 2c. Or, simplified out, 4 plus 8 plus 2c is equal to 4. And again, we got 4 because y is equal to 4. The function, when you plug in 2, equals 4. Okay? Subtract 4 on both sides, you get 0. Or actually, in this case, I combine them first, plus 12. And then 12 subtracted on both sides. So again, what I did here was 4 plus 8 equals 12. And then subtracted 12 on both sides and got negative 8. If you want, you could subtract 4 first, get 8 plus 2c equals 0. Then subtract 8 and get 2c equals negative 8. Either way, Algebraically, it works. Last and final step, 2c is equal to negative 8. Divided by 2 on both sides, you get c is equal to negative 4. So, simplified out, talking it through one more time. I know it's annoying. When we have an original equation, and you'll probably get one of these on the test, the AP test, they want the consonants. You understand that every single time you take a derivative, you usually lop off one part of the equation. So if we take the derivative, we get rid of this 2c and there's only b left. If we plug in our x value and our y value, then the only thing we don't know is b. We then solve for b. Plug in b into the original equation. It looks pretty standard. And then plug in the other number that we were given, the original equation, x equals 2, y equals 4, and solve for the only remaining variable, which is c. And that's it. Hope that helps. Here's the picture of the whole thing.